Alright, now that we have the implementation plan etched into stone for Canon 1, it is time for us to begin developing the actual program. What am I talking about? The coding phase. Now we're going to divide the coding phase up. Basically, we're going to have two videos. This video is going to focus on the mechanics of the game. No gameplay rules will exist. No game will truly exist when we get to the end of this video. Does that mean that we're not going to have anything that's going to feel playable? Negative. Logan will actually have a program at the end of this video where he sees a player, is able to move that player left and right with the mouse. He'll see a target object approaching down the screen. He will be able to hit his left mouse button and fire a projectile at it. And if it misses, well, he'll have to wait until his projectile goes off the screen. And if he hits it, it'll look like the projectile and the target were both destroyed, and the target will spawn once again from the top center of the screen, moving in a direction to the left or to the right. We'll have that in place. What we will not have is things like lives. So we're not going to be able to run out of lives each time the target hits the ground because they don't exist yet. We're not going to have a start screen that tells the player to click the left mouse button to begin. Again, those things fall up under gameplay, as we're calling it, and that's where we're going to wrap everything up into a true game. So the idea of this video is to get the mechanics into place. That's all. Now, as we begin the coding process, you guys should have a good idea of what we're going to do because we laid it all out in the implementation plan. So we have a pretty good map to follow. If, for just a second, you guys think back to that implementation plan, we had a section titled Utility Methods. And we had two methods in there. One was called getCenter and one was called distance. The distance one being the most critical here, where it basically calculated the distance between two of our controls on the screen. Just think of it as two of our objects. And in this case, I'm not wanting to disrupt the flow of the video as we are coding this game out and stop and give some 15-20 minute lecture on how the distance formula works. And to be honest with you, some of you out there probably are not all that rusty with your math skills, while I'm sure there are others that are rusty. So the way we want to handle this is we're going to code the game. Of course, we are going to explain what everything is doing. So if you're just a tad rusty, it's probably going to make complete sense. But if it makes no sense whatsoever, I just want to let you know now that we are going to have a follow-up video after the game is finished where we will be talking about the getCenter and the distance methods. We'll take a look at the code and we'll look at exactly what has happened. I'll break it down for you so it's just black and white, very easy to see. So keep that in mind. Don't panic as we work our way through the program here. The idea is I want to keep the flow as smooth as possible so that we don't get too far away from concepts, taking a look at something else, and then come back into the concept of, and I'm talking about the entire program being the concept here, and you kind of get lost as to what was going on 20 minutes ago. So with that, Logan, let's go ahead and begin. The first thing we're going to need is going to be, well, a Windows application.
Okay, so let's begin a new project. And that project will be a Windows application. The name will be Canon 1.
Bet you guys never saw that coming. All right.
So okay to that, and give it a second.
As it does all sorts of interesting things to generate.
And there we go.
There we go, our application. So now we have a very simple Windows application. Now, we need to go ahead and do a few things. Right off the bat, I'd like to make sure that we are not able to resize our window or maximize our window because we are going to be working with a fixed screen width and screen height. And Logan, right now, if you go ahead and hit run real quick, everyone will notice that Logan can resize this. So this isn't going to work for us. And he can also maximize it. Whoa, that was big. So we need to go ahead and set the appropriate properties here so that we cannot adjust the size.
Okay. We'll jump down to the Forms properties, and we should have one called Frame Border Style. We can change this from sizable to fixed single. And now if we run, we don't have any ability to resize. If we hover the mouse over an edge, we don't get the resizing icon and we can't grab the window.
Of course, you can see that we can still maximize it, so we need to go ahead and disable that.
Okay. Let me jump down a few more properties to where we have the here we go, maximize box. We'll set this to false.
Okay.
And now that takes away our maximizability.
Beautiful. So at this point, we cannot go in there and adjust the size. So with that out of the way, before we start really getting into the implementation plan, we knew right away that we were going to have a fixed size window. Let's go ahead and code in the size of it.
Okay. Let's actually jump in and get a few of the constants in place, the size dimensions that we were talking about in the planning phase. I'm going to jump into code this time using F7. Of course, I could have come over here and right-click to view code, but either way works.
So F7, it's a good approach for those of you that may have never seen that hotkey before.
Okay. Now we want to define screen size, so we're going to use two constant integers, one called screen width and one called screen height. So we'll do our first one, our const int screen width. And I'll set this one to 640. So we're going to have a window that's going to be 640 by 480. And then we need to do the same thing for height. So we'll have a screen height,
well, not height.
And
almost,
that will be.
We still need the H.
Oh, we do, I guess. Yes, we do.
There we go. You'll notice that this looks like a standard variable declaration with the exception of a new keyword. We've got const right before the type of the variable that we're defining. This means that we're going to have a constant, meaning that these two variables will not have a value that can be changed while the program is executing. So screen width will always have 640 in it, and screen height will always have 480 in it. So that's the key thing to remember. It's constant throughout the entire execution of the application. You'll also notice what we are doing with our casing here. Screen width and screen height, they're all capitalized. We are doing that to indicate to us later in code that, hey, these are constants. All right? Just a convention.
Right, it makes them very easy to pick out in code when you see the capitalized labels. Okay, let's turn around and use those now. The first thing that we're going to use our screen dimension constants for is to set the actual size of our form.
Okay.
So I'm going to jump down inside of the constructor for form1, and we'll set the form size, this class being the forms class. I can access it using the this keyword. So we could say this dot client size is equal to a new size of screen width by screen height.
Okay.
So we can run now to test to make sure that's working, and indeed it is. We now have a window that has a client area of 640 by 480.
Now, do not let it scare you when looking at this line and you see this dot client size. First of all, we're simply referring to ourself, being the form, and then we're saying equal to, we are creating a new object, a new size type object, and we're setting screen width and screen height inside of it, and that is what is being assigned into client size. And this is something that's going to be covered in great detail when we start getting into the true object-oriented lessons. Okay?
All right. So with that now, I think we can move on to the objects that we're going to have in the game.
Okay. Now we're dead on with our implementation plan, which started out with create the three objects, the player, the projectile, and the target. And in our implementation plan, we said that they were going to be picture box controls.
Okay. To drop down the picture box controls, I'm going to jump back over to design for our form. And I'm also going to pull up the toolbox so we can get to the controls themselves. Now, the control we want is the picture box. So I'll grab picture box and I'll drag one out. Not really worrying about the size because I'm going to set that manually in here in just a second. So let's see. As a matter of fact, to make this quicker, I'm just going to copy and then paste the existing picture box a few times just so I don't have to drag out as many of them.
And again, simple Control-C and Control-V.
And for now, I think we're done with the toolbox, so I'll close it up and give us some room to work with. Now, let's focus on these objects. These are going to represent our player, our enemy, and our projectile. So let's begin with the player. I'm going to select one of the picture boxes and set its name to player. I'm also going to set its dimensions. Since our graphics for the player are 32 by 32, I'm going to reflect that with the size of the player picture box.
Okay. Of course, this could have been set through code. In fact, later on, we're going to have to set everything through code when we start getting into the world of XNA game development, because we're not going to have a visual designer like this. But at the moment, we do indeed have a visual designer, and we have a properties window, so we're just making use of that window.
Okay. Now let's move on to the enemy and do the same setup.
Okay. So we got to name it first.
This will be our target, and the size will be 32 by 32 as well for the target object.
Okay.
And that just leaves the projectile. The name will simply be projectile. And the dimensions of the projectile are 8 by 8. So we'll plug that into size, and there we go. We have our player, our target, and our projectile.
Very nice, very nice.
Now, of course, we haven't set up any images, so if we run, we won't see anything. We need to have some images loaded in. And now this is where we're going to jump into code. We could, of course, set up the images as properties, but I do want to get into image handling in code just to get used to that.
Okay, sounds good.
So we can jump back over to the code. As a matter of fact, let me go back. Before I do that, I'm going to have the image loading code take place when the form load event fires. So I'm going to jump over to the form's events and then grab load.
And double click on it.
So inside of form load, that'll generate an event handler for us. Now inside of this event handler, let's load images into our picture boxes.
Okay, you want to start typing it out before we actually talk about the pictures themselves?
That is true. We have to get the graphics themselves.
That's right.
I can type it in, but it'll be
Sure, go ahead.
Let's address the player first. Since the player is a picture box, it has a load method, and load will take in, among other things, a file name of an image to load. The image for the player that we've got set up is called player.png.
And we're not doing anything fancy here to specify any type of directory structure where player.png is going to exist. So this means that player.png better exist in the same location as your executable.
That's right.
So we need to go ahead and get that in place. As a matter of fact, if you go ahead and try to run this, and here it comes, and we obviously have a problem because that does not exist, okay? And in fact, look at this in the troubleshooting tips. It says, if you go down a little bit, well, first of all, yeah, you get the one thing not existing up there. I love that first one in troubleshooting tips. Verify that the file exists in the specified location. Absolutely. So let's close that. Now, here's something that's really interesting. You have yet to save this, right?
That's right, and that's why that directory was in some odd place in the temp directory, as this project has not yet been saved. That means Visual Studio hasn't dropped the files into a specific place on the hard drive yet, at least one that we are aware of.
As a matter of fact, we can show them this if we go down and open up this folder. So here we are inside of our projects folder, and the only thing we've got in here is our backup projects, Hello World 2, and the Hyperion project. That's it. No Canon 1. So we're going to need to go ahead and save this project.
All right, let's jump in and simply hit Save All. This will bring up the dialog asking us for, or just verifying that we want to call the directory Canon1, which is fine. So we'll hit Save.
Now if we go back over, take a look. There's Canon 1. It now exists. Beautiful. So now we need to move our pictures over into the appropriate folder. Now, in regards to the pictures, go ahead and open up your other folder, Logan, where we've got all of our images. These images we are going to supply to you. Right now, these are just very quick temp images that Logan put together over in Photoshop. We will once again bring our artist in to come up with some more interesting looking images once we are done coding the game itself. So for now, you can use these, or you can jump into Photoshop or some other paint application yourself and create your own images that are, again, what we're doing, 32 by 32, 32 by 32, and 8 by 8. Okay?
All right, we need to get these moved over to the same directory that the executable will reside in. So let's find that directory. Let's jump into the Canon 1 project folder. Inside of that, we have our solution and then a folder that contains the source files. So we'll jump into the Canon 1 folder again. Now we need to jump into the bin folder, which is where the final output executable is stored. And right now we are building as debug. So I'm going to jump into the debug section, and there we have our Canon 1 executable. So now we can simply take these images, copy them, and paste them into the folder.
Okay.
So now if we jump back to Visual Studio and run, we have our ship player graphic loaded.
There you go. Like I said, very simple graphics for the time being.
All right. Now that we've got a graphic loading method down, let's load the rest of the graphics for the target and the projectile. The target, let's grab the target,
Okay.
and then load in a graphic called target.png. And the projectile will be the same thing, projectile.png. So projectile.load, and feed it projectile.png.
Alright, spelling.
And then I need
Missing
a
a
T
T.
somewhere. There we go.
Jetile. Almost. There we go.
Alright. Let's run and test this real quick, make sure that everything is working. And
so there we go. Very simple player, very simple object, and finally a very simple projectile. Very nice.
Okay.
Player, target, projectile. Okay? So now, going back to our implementation plan, the very first thing was create the 3 objects. We have now done that. The next thing was define some game constants. Now, we went ahead and jumped ahead and did this to begin with, only because we wanted to get our window locked down. But there were some other things that we needed to define as well. Things such as the projectile speed, base target speed, etc.
Alright, let's go ahead and get those put in before we jump into the game's code. Let's take our, let's see, the other 2 constants we have remaining are, like you said, projectile speed and base target speed. Both of these are going to be integers. First will be a const int projectile speed, and I'm going to set this to 12. Then we have a const int base target speed, and we'll set that to 8, or the other 8. That's not that one. There we go.
There we go. All right. Cool.
Now we need a few variables to track things as they're running frame by frame. Because, of course, we have things like projectile speed, which is just the fact that our projectile never changes speed. We can always use the same
speed.
So the
projectile will basically always move 12 pixels every game loop, if you want to look at it that way. Basically, every tick of the timer. Okay? Now, our target speed, our base target speed, is just that it is a base target speed, and this is something that we're going to use a little bit later on when we start getting difficulty into place, meaning that when the player actually shoots a target, then that target needs to speed up the next time around. So we'll start with a base target speed and then add a few things to it to make it go a little bit faster. But we do need to get some sort of target velocity X and target velocity Y that is going to specify how many pixels per timer tick we're going to move our target.
We also need to have the ability to have different directions. With the projectile, we only have one value, but that's because our projectile is only going to move straight up.
That's right.
The target is going to move at a random direction, so we need to be able to specify X and Y individually for the target.
That's correct.
So let's see. We'll define target velocity X.
You'll notice that these are not constants. This is just a regular integer variable.
Right, because as the game is running, we need to come up with new values for these in order to come up with new directions.
You got it.
And let's see.
Just go ahead and throw... Well, all right, go ahead and do that. I was going to say, just initialize them to something, like 2 and 5.
Okay.
Just so that when we get the mechanics in just a few minutes, that we'll actually see our target begin moving.
Okay, sounds good. Either way, or if we had done it the other way, it wouldn't look like it moves until we set this.
True. Well, we can demonstrate that in every different flavor in a few minutes.
All right. Now, one more variable. We need, in order to generate a random direction, we're going to need a random object in order to get those random values.
Oh, boy, that sounds confusing for those of you out there that are new to the world of object-oriented programming. Oh, .NET provides for us a random object, and we can utilize the random object for coming up with random values. And so what Logan's going to do, he's treating this like a regular variable. He is saying the type is random, just like you guys saw with defining target velocity X. The type was an int. Well, in this case, the type is random. Now a space. Now we need to give it the variable name, which is going to be random. So random is what is going to hold a reference to our random object. So now, Logan, you've got the variable set up, but we need to actually... generate a random object.
Right, because if we tried to access this right now, we'd actually get an access null because nothing is stored in random yet. It can hold a random object, but it doesn't yet.
That's right.
So let's make a random object and store it in the random variable.
Once again, we're dealing with the object-oriented world here. Do not panic if this looks a bit foreign. You've seen similar stuff when working through the Hyperion project, but again, this will be covered in great detail in Volume 2. So once again, Logan we've seen where we can say int x, and then on the next line we can say x equals 5. Well, this is very much the same thing where we're saying random equals, but now we're saying new random object, and that's going to create a new random object, and we're going to have a reference to that object actually stored in our random variable. Okay. If it sounds confusing, don't worry. Later on, that's going to become super clear. Just know right now that random, the lowercase random that we're using as our variable name, now just look at it as it's holding a new random object. Okay?
All right, now with that, I think we can move into some functionality.
All right, let's go ahead and compile. Let's make sure that we don't introduce any problems as we work our way through the code. Okay, beautiful. I do want you guys out there that's following along to get into a habit of building often, just to make sure you don't introduce some problem that seems to propagate its way through your code and make matters worse. Now, looking back at our implementation plan for Canon 1, after we get some game constants set up, which we now have, the next thing that we were going to do was make the player move along with the mouse.
Okay. That means we're going to need to handle mouse input.
All right.
In order to do that, I'm going to look back to the form to get one of its events. So we'll jump back to the designer, and then we'll
Notice the form is what is selected right now, not one of the picture boxes.
Right. So with the form selected, we need to look for the mouse move event. So coming down here, a little bit further down, there we have mouse move. Double click and have it generate an event handler. Now inside of mouse move, we need to be aware of the fact that the mouse move event is sending us information about the mouse through a mouse event args variable called E.
That's right.
So we can access the variable or the data held inside of E to figure out where the mouse is at.
And this is not any kind of black magic. This has already all been predefined for us. It's all set up, hooked up automatically. And now inside of this method, we have access to what's going on with the mouse through the mouse events arg type variable E. Okay?
So let's visualize the information that's being held in E by setting our player object to just snap itself to wherever the mouse currently is as the mouse moves.
Sounds fun. Now remember, how do we control setting an object on our screen? Well, it has a left and a top property that we can set.
Right. So let's do that. Let's take our player object and set its left property to be whatever the mouse's X currently is. So let's take a look at that E event args, or mouse event args. We say E dot, and there we go. We have things like buttons, clicks.
Wow, we can get to
bottom,
the buttons, we can get to its X and Y location on the screen, and all sorts of other cool things.
But like I said, the one I'm interested in is the X value.
And it makes sense. Think about it, because on the screen going left and right, well, that's going in X, positive and negative, if you want to look at it that way.
Right, and then, of course, Y would be up and down, so that's what we'll set for our top.
That's right.
So we'll take our player, we'll set its top to E.Y. All right, let's run and see what this looks like.
Okay, so it's moving around, but we've got some very interesting anomalies taking place right now. The first one, the most obvious one, is take a look at where the actual player is located at. The mouse is in the upper left-hand corner, because if I find my own pin over here, this right here, this area, I'm trying to move my mouse around very slowly, represents the top and left of this graphic, okay? So right up here. So we need to have some sort of offset if we want our graphic to be centered up on the mouse. So we'll take care of an offset in just a second. Now hopefully the second anomaly has become very clear, because I've actually been using it to my advantage here to demonstrate this offset that we need. Look at this. I am moving my mouse around, but I am not affecting the location of this picture box. Why is that? Well, if I come up here, it works just fine. But as soon as I travel back across the picture box, everything stops. And then when I get to the other side, boom, it snaps. Boom, it snaps. What's going on? Well, our picture box has a mouse move event of its own. And basically, it gets captured before any mouse move event back on the form. So right now, the form's mouse move event is not going to receive any mouse moving event, if you will, because it's being captured at the moment by the picture box. So the very first thing, Logan, we're going to need to do is disable this picture box. And while we're in there, we might as well disable this one and this one as well, so that then we can just simply move around and not have to worry about the picture box getting that mouse move event first, okay? Or not even first, just simply intercepting it and it never getting to the form. If we disable the picture box, then the form will always receive that event. Okay?
Right, that'll disable all input events for that control.
Exactly.
So let's do that first. Let's jump back to design. Let's grab our player picture box, switch over to its properties, and then scroll up, well, right here where we have enabled. We'll set enabled to false.
And we'll do the, I was going to say, let's go ahead and do the same for the other two real quick, just so we don't
while
forget
we're in here. So let's move on to our target. Set the same for that, set enabled to false, and finally do the same for our projectile.
Okay.
All right.
Now let's go ahead and run it, and let's take a look. Look at this. Very smooth. So as I'm moving in an upwards left direction, no problem. And as I move to the right, still no problem whatsoever. So the icon or the graphic that we're using here, the picture box, is basically always staying top left connected with the center of my mouse. So now we need to get that offset into place so that the picture box is centered up on the mouse.
As a matter of fact, we can do a few things, since we don't need it centered up in both X and Y, because the player is actually supposed to be constrained to the bottom of the form.
That sounds
So we
good.
could get that in place, since that's relatively simple, and then we'll address the centering up on the mouse.
Okay, that sounds fair.
All right, let's jump back over into code now and scroll down to our mouse move event. And let's take a look at top, because top needs to basically look like it's locked to the bottom of the form. If we set it directly to the height, though, it'll actually put the picture box right below.
Ooh, let me show that.
So we need to do a little bit of an offset.
So what exactly is Logan talking about? Well, here is our screen. And we have a height. So if I was to say, take my player's top, so basically, I'm just going to say P for player dot top, and set it to my screen height, where is it going to be? So this is my screen height right here. Let's pretend the screen height is 100. So if I set the top to 100, it's going to appear way down here. Right, the top of it's right at the bottom of the screen. See that? So we need an offset in place to make this guy actually appear like he's sitting on the bottom. Well, to mirror this over, what do we need to do? All we need to do is take into account the height of the actual picture box that's holding our player graphic. So if we say that it's equal to our screen height minus the player's height, that's going to allow us to push it up so that we're sitting, what appears to be sitting on the bottom of the screen.
That's right.
Okay?
So let's jump back over to Visual Studio and do just that. Let's take our top and we'll set it to our screen height, which we have conveniently stored in our screen height constant. So we could say player.top is equal to screen height minus our player's height. Alright, so screen height minus player height.
Let's test it out.
And there we go.
Ooh, look at that.
So no matter where I move the mouse, the player stays constrained to the bottom of the screen.
But the player's not centered up on your mouse. Look at that. There's still that offset where basically he's sitting to the right of your mouse.
That's right. So we need to, again, take the player's width into account so that we can center it up. So to start off, let's do something simple. Let's just take the player's width and apply that as an offset. So we'll take our mouse's X and we'll subtract the player's width and see what that looks like.
Okay. So basically what we have now is our picture box on the other side of the mouse. So let's go ahead and close that, Logan. I'm going to bring up the whiteboard real quick. Let's see if I can give some sort of demonstration as to what is happening. Now in this particular case, what I want to do is just focus on, here's the bottom. Here is our graphic. Let's just say here is the mouse. So basically at the moment our left is set where the mouse is located, and that's why we are to the right of the mouse, because the left of course being on the far left side of the picture box itself. What Logan just did was said, alright, let's take the picture box, let's take its width right here and subtract that away from where the mouse is at. So we just in essence mirrored it over to the other side. That is why, as he's moving his mouse around at the moment, the picture box is on the left-hand side of the mouse. Still not exactly what we're looking for. We're looking to shift it over only halfway. So what if we were to tell it that we wanted to use the mouse's X location, and then from that we want to subtract away the player's width, but divide it by 2. So instead of subtracting the entire width, we only subtract this little 50% part right here. So 50% of it, which now we're going to have that. So it's going to be centered up on the mouse's location.
Okay. Let's jump back to Visual Studio and scroll down to where we have our width offset, and we'll divide the player's width by 2, so that way we're doing an offset by half of the width instead of all of the width.
Okay.
And look at that.
Very nice. I like it.
So really that takes care of the player movement. We now have it based on the mouse, but constrained to the bottom of the screen. And we've also got the proper width offset so that it looks like it's centered on the mouse.
Awesome. Now, taking a look back over at the implementation plan, we've got our 3 objects in place. We've got our constants in place. We have followed the next instruction, which was make the player move along with the mouse. The next thing is we're going to add a timer, and we're just going to simply make our target object move and our projectile move.
Okay. And so let's jump over to design now, and we need that timer object. So I'm going to bring up the toolbox, then I'm going to jump down to the component section and grab a timer. I'll drop the timer onto the form, and you can see it appear in an area below the form. Now, just to make this make a little more sense, I'm going to call this our game update timer. And I'm going to set it to be enabled as soon as the application loads. So I'll change enabled to true. And finally, I'll change the interval to 16. So we get roughly 60 frames a second game update speed.
Okay.
So with this running now, I can jump into its tick event, and instead of switching over to the events in the properties window, I'm simply going to double click on the timer itself. Since it has only one event, that is of course its default event, and we get a tick event handler created for us.
Okay.
And I'm also going to close out the toolbox so we get our coding area back.
Now we're going to keep things very simple right now. We're not going to worry about, we're just going to make the object just simply move down, right? And the projectile simply move up.
And since the projectile has only one variable in order to consider its speed, we're going to do the projectile first.
Sounds good to me.
The projectile only moves vertically, so we only need to address the projectile's top, and we simply need to move that by our projectile speed.
Okay.
So let's take a look at that. Let's take our projectile, and we'll set its top. Now we'll take its top and we'll add 2 tops, so we'll say plus equals whatever our projectile speed is. As a matter of fact, let me look at that. I think that's actually minus, because since we're moving,
going to make it go down.
Since we're moving up the screen, towards the top of the screen is towards 0, so we actually need to take away from the top in order to make it move up on the screen.
That's right. So if you go ahead and hit play right now, what's going to happen is it's just going to zoom right off. As a matter of fact, go ahead and close that, and let's change our projectile speed. See, here we go. We have constant set up. A very simple place, one place where we can go and code and make a change, and every place else that utilizes projectile speed just automatically respects it. So let's change it to maybe something like just 2.
Okay. And there we go. We have a much slower speed so we can see the projectile for a while before it goes off screen.
Now the funny thing is, once it goes off screen, of course it does indeed continue to move. You know, it's going to be located at -2, then -4, then and it just continues to do that and do that and do that. Now, of course, variables can only hold numbers so large. With a value of 2, we're probably looking at more like 70, 80 days of continuous running time for the application before our number ends up getting a little bit too big.
Even more than that. I had it.
Actually, that's right, because at 12 you had 35 days, didn't you?
Right.
Whew, you're going to have to let this run for a long, long time. Alrighty, so that's something we're not worried about in this game. We're going to keep it as simple as we can. I just want you aware of the fact that right now we do indeed have a moving projectile, even though you don't see it moving. Now, when we get over into more professional game design, what are we going to want to do in a case like this? How about destroy it? Get rid of it. Kill off that object. Okay? So let's go ahead and hop out of here. All right, now let's continue on. Now that we have our projectile moving, we can take a look at making our target move.
Okay. So let's take our target object. We'll set its top to be incremented by whatever is in our current target velocity y. So we'll have the target set to, or let's see, target.top plus equals target velocity y.
Okay.
And then we also need to address x and address x separately. So we'll take our target's left and increment that by our target velocity x.
Now, before you go ahead and execute, go ahead and scroll back up to show them. There we go. Where we had set these, we initialized both target velocity x and y to values 2 and 5, which means we're going to be moving down a little bit faster than we are going to be moving to the right in this particular case. So let's go ahead and run. And there we are moving to the right, but we are moving down faster than we are moving to the right. But once again, it's off screen, and it just goes and goes, and it goes on forever. Well, until the number becomes too big to be taken into account. So let's go ahead and close this. All right, very nice. So next, we've got it actually moving. Now, do you want to go ahead and, because right now we're not using our base target speed. Do you want to just tie that in real quick?
Well, let's see. We could handle collision, or we could, because the base target speed is only taken into account inside of the reset target.
Okay, it was just something we had talked about previously, and it would show them a change in speed. But that's okay, because the next thing, if we're going to follow our implementation plan, I don't want to jump around to any sort of collision or anything yet, because the next thing, according to our roadmap, was to go ahead and skeletal out all of our methods.
Okay.
So we're going to go ahead and start with, now remember, we had divided it up in the implementation plan to where we were going to set the skeleton gameplay methods first.
That's right. We need to get these methods put together in such a way that it will act kind of like Hyperion, where we can address any other method from any method that we want and not worry about that method not existing yet.
Exactly. So I'll say that we met our needs right there in the implementation plan. We did indeed make the projectile move, and we did make the target move. Okay, so time to get some skeletal methods into place.
All right. And we're going to focus on the actual gameplay methods first, things like firing the projectile. Now, before I skeleton in these methods, let me define a region for all these methods, because we'll have a few different categories that we're going to put together. So we'll make a region, and we'll call this region gameplay methods. And then we'll end the region. All right. Now, the first gameplay method is firing the projectile. So we'll have a private void method called fire projectile.
Okay.
And let's see, what do we have next? We
next
also have
reset target.
All right.
Actually, in this case, why don't you do reset projectile?
Just to keep the projectile stuff in the same section.
Yeah, that sounds good to me.
All right. We'll have another private void, and this time it will be reset projectile. And then finally we need to put in reset target. So we'll have a private void reset target.
All right, and that's our gameplay methods. Now we're going to take a look at our two collision methods.
Okay. Let me define a region for collision methods.
Okay.
So I'll make region collision methods. And end the region. All right, first collision method. We've got check ground collision. This will again be a private void method called check ground collision. Now check, let's see. Yeah, okay, we've got check ground collision in place, and then next we have check air collision.
That's right.
So we'll have our private void check air collision. All right, and that should take care of our collision methods.
Okay, the next section was going to be utility methods, if you want to region that in.
All right, a region for utility methods. All right.
And the first one was going to be get center.
Okay, so again, private, but this time we're going to be using this method to return a value, and this one, get center, is going to return a point.
And a point's going to be a nice way for us to put an X and a Y piece of information together.
So we'll have private point, get center, Now getCenter its purpose is to get the center of a control. So we're going to need to feed it a control as a parameter. So we'll say that we're going to feed it a control, and we're going to call it control C. Now, just to make sure that this code would compile, I'm going to put in a temporary return value.
Okay.
So I'm going to return a
new point. This is just so that it will compile. All right, very good. So we got one more to do, which is going to be distance, because remember we used getCenter to find this. Well, we're going to be using getCenter to find the center of our objects that we're going to need to figure out the distance between. So now let's go ahead and define the skeleton for our distance method.
Okay. So this will again be private, but it's going to return a float. So I'll have private float distance. And distance is going to need to take in the 2 points that we're measuring.
Okay.
So we'll have a point A and point B. So I'll have point for point A and a point for point B. And again, I'm going to put in a temporary return just so that we can build the code.
Okay.
So we'll return 0 for now.
All right, sounds good. Let's go ahead and build and make sure everything's happy.
And
we're looking good.
Looks good.
Okay, so turning our attention back over to the implementation plan, we've now got the skeletal methods in place, so now it's time to have a little bit of fun. Next, what we had was the gameplay mechanics, starting out with make it so that we can fire the projectile.
Okay, let's jump back up to where we have our fire projectile method and get that put together. As a matter of fact, let's first set up our code so that we have a form event in order to call this, because this is just our own method. Nothing's going to call it automatically. Let's jump over to the form, grab its events, and let's grab a mouse down event.
Okay, so when the mouse button is pressed down, we're going to fire off the code within this event.
Okay, and that code, of course, is going to be the fire projectile method that we've just defined. Now, I want to take our code. We see we had our regioning set up for all of our custom methods, and now we've got that being basically placed between two different event handlers. We had event handlers higher up in the code, and now we have a new one at the bottom of the code.
And custom methods in between the two, so you want to keep everything nice and organized.
Right. So I want to grab this new event handler and actually move it back up.
So he did a Control-X to cut it out, and he's going to move all the way back up to our events.
So here we have the game update timer, which was the last event we put in before mouse move. And while I'm at it, I think I might as well go ahead and put in some regioning around the events.
Okay.
So we'll say this can be a region called events. So we'll end that off. All right. So we've got an event that calls fire. Now we need to put the code into place for the fire projectile method.
Okay.
Now, fire projectile, since we're not really making a projectile or spawning a projectile, all we're doing is taking our one projectile object and setting that to a location that is just in front of our player graphic.
Okay. Oh, that's going to mean some more offsets because we're dealing once again in the world of left and top.
Right. And to begin with, I'm simply going to use the left and top of the player just so we can see where it would be before offset, so we get an idea of what kind of offsets we need.
Sounds good.
So let's take our projectile, set its left to be equal to the player.left, and set the projectile's top to be equal to the player's top property. Alright, now we should be able to test this and see something happen. So let's run, and if we hit the mouse button, there we go.
It comes out of the top left of the picture box.
So it looks like we're kind of firing it from the left wing of the player.
Yes, it does. So right now, if you go in and you set the velocity of this, basically its projectile speed down to 0, it's just going to simply move, and we can see where it spawned from if you want to look at as if it was spawning, basically where we moved it
right.
to.
Since right now it could be hard to see where we need to do the offsets, since we only get a half a second before it moves away and we have to refire to see where it is.
Yeah, let's go ahead
and
do
that. Like
that.
you said, we could take our velocity or our projectile speed all the way to 0, which will make the projectile stop. So there it stopped. If I fire now, it simply gets set to the player's location and remains there.
And now we can see it is indeed the top left of the picture box. So now we need some offsets into place, several of them, or at least 2 of them. We need to center up the button on the ship, and then we're going to, or not the button, excuse me. We need to center up the projectile on the ship, and then we need to move it up some so it doesn't look like it's being generated in the cockpit of the ship. Okay?
Right. Let's look at the horizontal offset first. Then, judging by what we did with the mouse offsets, where we took width as our offset and divided that by 2 to center it, looks like we could use something similar for the projectile. So let's jump back to fire projectile and take a look at left. We know we're going to need an offset, so let's just look at our player's width. So if we offset, so if we take our player.left, but then subtract from that the
actually you don't want to subtract because you're going to want to go the other way.
Right, if we subtract, we're going to go more left.
Do a subtraction real quick. Show them.
So if we subtracted player dot
we're in no rush here.
Width. Let's see what that would look like.
We're going to push the width of it even. It's going to be moved further away by the width of the picture box that's holding our player. Go ahead and click. There you go. It's moved further away from it. So we don't want to minus in this case. In this case, we want to add because we're going in a positive direction. So just try adding it just to show them that it's going to put us on the other side of our player. And it's now on the other side. All right, so now we're going to need some divide by 2's in there, and even that's going to pose a bit of a problem, I bet you.
Because now you've seen it on both sides, so you might be thinking, well, it's just a matter of dividing the width by 2, so we only offset by half of the width.
Okay.
So let's take a look at what that actually looks like.
Which is good thinking. Now watch what happens. Oh, it's still offset just a little bit too much to the right. Why is that? Well, now we need to start accounting for the width of the projectile itself. So we need to also subtract away, because we need to move. Which way does it need to move?
Well, it needs to move left some.
It needs to move left. That means we're going to need to subtract. How much do we need to subtract? Well, not the full width of the projectile, because then what's going to happen? The projectile is going to end up on the left side of the cockpit. Right now it's on the right side of the cockpit. So we need to move left by the projectile's width, divide it by 2. Only half of the width of the projectile.
Okay. So let's drop back in here, and let's take, we know we need to minus, so we're moving left.
Right.
We're going to take our projectile's width, then divide that by 2.
Beautiful. That should work great. All
There
right.
we go, dead center.
Now we've wiped out the cockpit. Excellent. Now what we need to do is worry about our vertical offset.
Right, because right now the top of the player graphic and the top of the projectile are at the exact same place. We need to move the projectile up, so in negative y, by however high it is. So that way if we took away the height, then it would be sitting right out in front of our player.
Yeah, you just take it to where the player's top is and subtract away the height of the projectile.
So grab our projectile, subtract its height.
Yeah, and that'll do the trick right there. It'll put it right up at the nose. So the bottom of the projectile will sit at the top of the nose of our ship. And here we go. Click. Oh, beautiful. So now we have it lined up. We can go ahead and set its speed back so that it moves and it'll look like we're actually firing it. Which then we're going to see another problem. It just keeps getting better, doesn't it, guys?
All right, we've got our speed set back to 12.
So he fires. Ooh, check it out. We can now fire. Now, rapid fire. Yeah, rapid fire is not shooting out a whole bunch of new projectiles because we're not quite yet to the phase where we're going to introduce the ability to create multiple projectiles. This game is simple. Remember, back to our requirements for cannon. One projectile is all that can exist on the screen at any given time. So, now we've got to think about the rules that we put in place. Since we can't have more than one on there at a time, when are we allowed to fire again? Well, basically, when the projectile has moved off the top of the screen. So basically, when the projectile's bottom is less than 0, since the very top of the screen is, let me grab a mouse. Here I am just talking. This right up here is 0. Follow the mouse, not the player that's moving. That's 0. So the moment our projectile gets above 0, which is what? -1 or whatever it may be, negative something. As soon as the bottom of it is above, we don't want to start the moment that the top of it goes above, because that means you can still see part of the projectile. And you don't want to be able to fire again then, because it'll just snap back down here. And we'll be firing the same one again, of course, but you don't want that snap. So you want to check for the bottom of the projectile being less than 0. That means that the projectile has completely moved out of our playing area, and at that point, we can fire again and simply snap it back down. So, Logan, I think this calls for a very simple if statement.
Okay. and we need to do just that. Let's put that check into place when we attempt to fire. So back to the fire projectile method, let's start an if statement so we can do this check, and we're checking for the projectile's bottom to be less than 0. So I'll jump down, block that in, and to finish off the block, I'm
watch carefully.
Going to
This is very nice, guys. He's going to finish off the block and watch the auto formatting that happens.
So I'm going to jump one line down below our code we have, put the finishing block character in, and then that automatically tabs all the code from within the if statement.
Gotta love Visual Studio. You just gotta love it. Okay, very cool. So let's test it out.
So here we fire, and we can't, even though I'm clicking the mouse as fast as I can here, we still only get one projectile shot per, or one projectile at a time on the screen.
That's right. Even though it's not multiple projectiles, it's just the illusion of multiple projectiles. Okay? Very good, Logan. Now that we've got that gameplay mechanic in place, make it so that we can fire the projectile, the next thing we need to do is turn our attention over to our target object. We need to check for our target object hitting the ground.
Okay, and that's going to be our check ground collision.
Okay.
We're going to be done with that. Inside of check ground collision, we need to look at the target, and we need to see if the bottom of the target has hit the bottom of the screen yet.
Right.
So this could be a simple check where we do something like, if the target dot bottom is greater than our screen height.
Meaning you're not worried about it moving 1 pixel past.
Right, I'm not worried about
That's right.
just hitting it. It can go a little bit past. And if that is indeed the case, if the bottom has passed, the bottom of the target has passed the bottom of the screen, we'll count that as a collision with the ground.
Okay.
So let me block in this if statement. And what do we want to have happen in a ground collision? Well, we want to, for now, just reset the target, because that goes along with our gameplay rules, and that is that as soon as the target hits the ground, it respawns at the top. So we need to call upon reset target.
That's right.
All right. Now, of course, we could build and run, but there is nothing inside of the reset target method yet. So I think we should focus on that now.
That's probably a good idea. And, of course, in our implementation plan, that is exactly what we need it to do.
Okay. Now, inside of reset target, we need to do two major things. We need to come up with a new velocity, because, of course, we could be moving in a new direction.
That's right.
And we need to reset the position of
right.
the target. So let's focus on velocity first. Let's come up with some values for velocity. And let's focus on target velocity x first.
Which is basically going to control if we're moving left or right. And by how much we're moving left or right, how steep that angle is.
Now, of course, moving left and right, that's what's going to dictate our direction. Since we're always going to move the same, for now we're going to move the same speed down all the time. We're not going to get into advancing in difficulty and making it faster just yet. We are going to vary in our speed left and right, so our speed x.
Let's have some fun with this. How about we code all the way through reset target without randomizing it?
Okay.
So that we can show them ahead of time. We're going to set it to -2, so we know that it's going to be moving in a left direction.
Okay, we can do that.
And then as we get everything in, and they can basically see it marquee, so it gets to the bottom, then pops back to the top and goes again, and then we can go back in and put the randomness into it.
That sounds good. It'll make it a little bit simpler to see what each piece does.
Exactly. So just set it to -2 or something.
Okay.
Yeah, that sounds good.
And now let's look at target velocity y.
Finally, we can put base target speed into play.
And that's exactly what base target speed is for, is to give a base value for our target velocity y. So here we'll set this to base target speed. And yeah, that should work. So we've got, for now, a hard-coded direction.
Okay.
And we've got our speed and y set.
Okay. Now, let's go ahead and, at this point, remember we said that we needed to make it look like the target was scrolling down onto the screen, not just snapping or appearing right there at the top of the screen.
Right.
So what we need to do is set the target's top so that it's above the screen, okay, by the height of the target itself.
Right, that'll put it just off screen,
exactly,
above the screen.
So let's do that real quick.
All right, let's take our target's top and set that to... Now, just above the screen would be something like, if it's 32 pixels high, that would be -32. And of course, we'll just access the height of the target. So we'll say that the target's top is equal to the negative target dot height.
Beautiful. Okay. So, which obviously, there's no reason for us to say 0 minus the target's height, because what is minus target.height? Well, the target's height is 32, so that's negative 32. What would be 0 minus 32? Negative 32. Just keeping things simple. As a matter of fact, Logan, let's go ahead and run it real quick. Watch what happens. We're not worried about centering anything yet. So tink, and then, oh, this is great. We're not even calling on the check for collision yet. We've got the code in place, but when does this method actually get checked? We're not checking it. So let's go ahead and hook that up real fast.
Okay, I'm going to jump back up to our timer where we were moving everything around. Since we don't have any event for this, this is just something arbitrary. It's a positional value.
Right.
We need to check for that ourselves. So I'm going to jump into the game timer so that every time we have the timer move something, we then need to check and see if that move resulted in a collision with the ground.
Okay.
So this is where we'll do our check ground collision.
Exactly. So basically we moved our target in Y, and we moved our target in X, and then what did we do? We checked to see if we've collided with anything, which means we're going to make a call down to the check ground collision. Let's go ahead and scroll down there real quick. So now here we are at our check ground collision, and now we're simply saying, hey, did the target's bottom happen to go past the screen height? And if yes, let's go ahead and reset it. So let's bounce up to reset real quick. So now we're going to call reset. Up here at reset, we're like, okay, well, what we need to do is go ahead and set the target velocity X, which, what does that do? It simply determines how many pixels we're going to be moving every tick. Well, let's set it to a -2. Well, what's that going to do for us? That means at this point, our target is going to move 2 pixels to the left every timer tick. And then we say set our target velocity Y to our base target speed. Oh, that's pretty funny. So let's scroll back up real quick. Our base target speed is 12. Or I'm sorry, 8. I'm looking at the wrong one. Yeah. Base target speed is 8, but look at the target velocity Y that Logan initialized that variable to. It's 5. So the very first time it goes off screen and comes back, we're actually going to see it speed up. So that's going to be pretty funny. All right, let's scroll back down real quick.
All right, jumping back down to check ground collision.
All right, actually back up to the reset.
Oh, you want to reset?
Yeah.
I got you.
All right, so now that we've actually sped up in the Y direction a little bit, the final thing we need to do is say take our target and move it right above the top of the screen so that it'll smoothly scroll on. Now, we are not doing anything to center the target up on the screen yet, so keep that in mind. Let's go ahead and check it out. So off, bink, and going the other way, and a little bit faster. Aha! All right, and it just keeps going. Very cool. All right, so now we can close that. Let's first go ahead and put in the code to handle the target's left such that the target is centered up on our screen.
Okay, and that will be target.left. We'll set that to our screen width divided by 2, so the center of the screen. Then, of course, we need to offset and center up on the target itself. So we need to take our target's width divided by 2. So we get the center of the target placed on the center of the screen.
Exactly. Let's go ahead and run it. And here we go. So it goes off now, centered. Ooh, going that way, and it's just going to keep doing that. Now we can demonstrate with ease. Go ahead and close the app and change -2 to just 2.
Okay.
And when it goes off, ooh, now it's going to always go to the right. 2 pixels every timer tick. All right, so let's close that. Now that you guys have seen the basic mechanics behind reset target, let's go ahead and randomize our X direction.
Okay, let's replace this hard-coded value with a call to our random object. So we can use this by saying random.next, so we have random pull up its next value. Now for the X, I'm going to specify a range for random. If I jump down to the parameters that are accepted, we have one where we can take in a min value and a max value for our random.
And read very carefully the summary we get down there on min value. The inclusive lower bound of the random number returned. Inclusive. That means, Logan, what number do you want to start with? 2?
Well, let's have it start at 2.
Okay. That means 2 is one of the possible results that can be generated by random here. All right, so now go ahead and put a comma. All right, now you notice it moves over to the max value. Let's take a look at this. The exclusive upper bound of the random number return. What does this mean? Well, it's exclusive. That means that, what number do you want to use? Say 6 or so?
Let's have a range between 2 and 5, which means we'd have to put a value of 6.
There you go. And that is going to give us just that, 2 and 5. 6 is exclusive, so 6 is not going to be included. It would need to be inclusive if it was going to be a possible result of this random generation. So in this case, it's between 2 and 5. I just wanted to point that out because it's very easy to miss that.
Okay. So with this, we could go ahead and test and just see what random values we're getting.
I can already see a problem we're going to have, though. It's just always positive. We're always going to be moving in the right direction. So it's always going to move into the right. Perhaps the angle is going to get a little steeper. Oh, no, that's okay. Let it run.
Okay.
Let it run. So let that one, there you go. Now watch this. The angle, there you go. Angle's a little steeper, not quite as steep. But it's always going to the right because the number we're generating is between 2 and, well, it's between 2 and 6. So, I mean, it's a 2, 3, 4, 5, basically.
Right. So we need to come up with a way of saying maybe give a 50-50 chance for it to go in the other direction.
Okay.
So to go negative x. So let's do that. Let's do another check on random and see if, and let's generate a 50-50 value.
All right.
This check will, of course, have to be an if statement. And inside of this, let's generate a random number. So we'll use random.next. And this time, I'm going to feed it a single number to specify a range. And this is going to be basically just the upper bound, so that our lower bound is 0, and our upper bound will be exclusive. So to get a value, let's see, for a 50-50 chance, I'm going to generate either a 0 or a 1.
And since in this particular case, the exclusive upper bound, ooh, there's the word exclusive, so you'd want to put 2 in here. That would give you the possibilities of 0 and 1. There's your 50-50.
So if this random value, let's say it was equal to 0, because half the time, or 50-50 chance of it being 0 or 1. If it was 0, let's say that we'll reverse the x in this case. So let me block in this if statement. And now we'll take our target velocity x, and we'll just multiply it by -1 so that we get the velocity reversed. So we'll say target velocity x times equals -1.
Okay, very good. Now let's see what we get. All right. Of course, we're not resetting it to begin with. Ooh, steep angle. Not quite as steep. Still going to the left. Still going to the left. Hang tight. And to the right. And back to the left.
So we just hit a really left-heavy
set
of random values.
But there we are. We are indeed going to the left and to the right with varying angles on our target object. Very cool.
All right. And really, I think that takes care of, well, most of reset target.
Yeah, I think that's everything for a reset target. Now let's go ahead and look back over here at the implementation plan. So now we've got make it so that we can fire a projectile, check for ground collision, code in the target spawning, which we just did basically, which is reset target. The next thing is code in projectile target collision. This is, as I said back in the implementation plan video, this is where things are going to get the most complicated for this particular program, because at this point we need to go ahead and code in our 2 utility methods, the get center and distance, because we need to use those in checking to see if our projectile has collided with our target object.
Right, and there's a key, checking a distance. And thinking about this, it might be a good idea to go and throw in an extra constant, so we can say what width are we actually checking for, because we know that the target has a radius.
That's right.
And the projectile has a radius. And we want to check the distance between those two, and how close do they have to be in order to cause a collision.
Before they must be colliding. Okay, sounds real good.
So let's jump back up to our constants, and let's add in another one. We'll have a constant. We can make this one a
collision distance. Oh, okay, yeah. I'm sorry. Go ahead.
Make this a float, because again, if you remember from the distance method or utility method we defined, that returns a float.
Yep.
So we'll define a constant float. And
I was going to say call this collision distance.
Right. This will be collision distance.
Now say that you don't just throw a magic number in there. Come up with a number. How are you going to do it? Say it out loud.
Okay. Well, in order to come up with this number, let's look at...
While you're talking, how about I draw it out over here?
Okay. Well, we've got our target, and we've got our projectile.
So here's our target.
And both of those have dimensions. The target is 32 by 32.
So 32 by 32. Okay. And then we have our projectile, which is
8 by 8.
8 by 8. So now, if, of course, this is a circular type thing, we're interested in this radius. So we're interested in half of this.
So that would be a value of 16 for the target, and a value of, is that That's 4 for the. I see what you did.
Yeah, and I just moved over here to this guy, so we want to. So same thing. That's okay. For a second, you made me go, huh? So now we're going to take this guy, same thing, because our projectile is a circular shape. We're going to say 8. Again, we're going to divide it by 2 to come up with the radius of it, which is indeed 4. So now we've got 4 and 16. So if we were to add these two together, 16 plus 4 is what?
Oh, that's 20.
20. All right. So that'll be our collision distance.
So let's go and plug that in now. That's how we came up with collision distance. And since this is a float, I'm going to define this as 20.0f, just to make sure that this value is indeed a floating point value. All right. So now let's focus on what we need to do in order to get check air collision working. As a matter of fact, we might move into.
I would highly recommend we go ahead and do get center and get center and distance in place first, because we need to use them.
So let's focus on get center. We do indeed need to return a new point, but what values is that point going to contain?
Right.
Well, it needs to be the location or a location located at the center of the given control. So that means we need to look at things like the control's top and left for its location, and then come up with an offset, which will be using width and height divided by 2 to find the center.
Exactly. Now, if you guys recall, at the very beginning of this video, I said for the get center and the distance methods, do not get worried if you do not understand what's being typed. I am going to create a video for you where we will take both get center and distance, look at the code very closely, along with whiteboard examples so that you understand exactly how we're generating the numbers.
Okay. All right. So if we're getting this centered point, let's take a look at our control. We'll take its left. This, of course, being the first parameter to point, so this value that I'm coming up with is going to be the point's x value.
That's right.
So we want to look at the control's left, and we want to offset that. So we're going to add onto that its width divided by 2. So that will give us the center in x, or the center left for the point.
Okay.
Now we need to do the same thing for y. So I'm going to break this up. Now we have our second parameter. You can see there our int y. Now I'm actually going to jump down onto the next line just to make this clear as a separate value. So this will be our control's top plus our control's height, again divided by 2. And
many of y'all, I'm sure, have no problem seeing what's going on here. Again, this is only for those that are rusty with the math. We will be breaking this down, but it's really straightforward.
Okay. And just to make sure that there's no syntax errors, I'm going to build just to make sure that everything is working good.
All right, piece of cake.
Now we can focus on distance.
Yes, Pythagoras. We can use the Pythagorean theorem here to get it.
Okay. I'm going to jump down or throw return down a few lines. Now, to make this a little bit more clear when it's written out, we're going to use the variables a, b, and c.
Okay.
And, of course, there's other ways that this can be written out.
Sure, we're just going to keep this as close to Pythagorean's theorem as possible, where you have a squared plus b squared on a right triangle is going to equal c squared.
Right. So let's define some of these variables. Let's have a, b, and c, or a and b will be integer values, since we've got integer values for these points. So we could have an int a, and that, of course, representing side a, and that is the value of our point a's x minus our point b's x.
Okay.
So int a is equal to point a dot x minus point b dot x.
Okay.
Now we have our side b, so int b is equal to point a dot y minus point a dot y. And now finally,
go ahead and change that equals real quick.
Whoops, I meant equals, and I mean minus and that, or you know what I mean.
Yep.
All right, and for side C, I want to set this up as a float since we're returning a float, and the result of finding the distance between point A and point B is probably going to be a float after we divide it. So I'll make a float C, and we'll set that equal to, let's grab the, we know we need the square root, because again, we'll be getting into the distance formula in the next video. So we'll have our float C is equal to math.square root, and let me go ahead and throw this in, so square root of a squared plus b squared. So in order to get a squared, I'll simply take a times a, but just for clarity's sake, I'll then take that and throw parentheses around it. I know these aren't strictly necessary because we're multiplying.
That's correct.
But it will make it a little bit easier to read.
Operator precedence.
So we have a squared, or a times a, plus b squared, or b times b. And finishing off the parentheses, we finish off the square root, and then terminator. And there we go. We're getting a squared plus b squared, getting the square root of that value, and storing that in C. Though you see, if we try to build right now, we actually get a build error because square root returns a double and not a float. So we need to convert that over to a float.
And this is casting, which is going to be something we're going to talk about later when we revisit variables. Now let me go ahead and take just a second.
Actually,
go ahead.
Yeah, I was just saying I'm one step away from finishing this. If I take our return now
and just set it to
and
C.
return C, then we've got the method finished off. And I could build to prove, and there we go.
There you go. Now real quick, even though I'm going to break it down in the next, let me go ahead and kill all of that, in the next few videos from now, I just wanted to point out what we were doing here. So here we are, right triangle, object A, object B, and remember how the Pythagorean theorem works. Basically, we've got A, B, and C, and the formula says that A squared plus B squared equals C squared. Well, if we want to get rid of the C squared and just have it as C, we could just find the square root of these two. So this is going to become C equals the square root of A squared plus B squared. And that is exactly what Logan just did. So we have an object right here, we have an object right here, and what's this right here? I don't know. Looks like the distance between those two objects to me. So there you go. That's what we're doing.
Right, just a quick explanation of why we plugged in these numbers in this way.
A very quick explanation.
All right,
very cool. So now that we have our two utility methods in place, let's use them now.
Okay, so we'll turn our attention back to check air collision.
Okay.
Now the first thing we need to do here is to get the center of the target and the center of the projectile.
Okay.
And store those in 2 points that we can feed over to distance.
And points are just simply variables of an object type point.
Right. So the first one, let's look at the projectile center. So we'll make a point. We'll call this point projectile center.
And so what I just said didn't seem confusing. Here's what I'm talking about. Logan is creating a variable that's going to be holding a reference to a point.
And to get this point, we're going to call upon get center. So say that projectile center is equal to get center, and then we'll feed in the projectile controller, projectile picture box. So we feed in projectile, and there we go. Now we need to do the same thing for the target. We need a point. This one will be target center, and this again we'll use get center, but this time we'll feed it our target object.
Okay.
Now we can take our 2 points and check their distance. So we'll check this with an if statement. We'll say that if the distance between the projectile center, so there we go with our projectile center, and our target center, if that value is less than whatever our collision distance is, then we have a collision. So we can check this against our collision distance,
which is at 20. So when at 20, that means they're touching or right at touching. But as soon as it's less than, they've gone through one another. They have to be colliding.
All right. So let's finish off the last parenthesis for the if statement.
Okay.
Jump down and block this in.
Okay. So what are we going to do if we have a collision?
Well, first we need to reset the target so that it looks like the target's been hit and has to respawn. So reset target. And we're also going to reset the projectile so that it, again, looks like it got hit and destroyed. So reset projectile.
Now we've already coded in the reset target, but we have not yet coded in reset projectile.
But still, we should at least see the target get hit and reset.
Absolutely. And the projectile is just going to keep right on wandering up the screen.
All right, let's take a look. Here we go, and if we hit...
And are we calling ever to check for a collision?
We're not.
That's right.
Same as we did before. When we had made ground collision, we made it before we actually called upon it.
So back up into our timer.
Let's jump up to our timer, and right after we check for ground collision, let's check for an air collision.
All right.
Now, let's take a look at this.
Ooh, very nice. Ooh.
I think I've got one of the points messed up.
I think so too.
It looks like X and Y got messed up somewhere. So let's take a look at probably distance. And I didn't change
B, over to the right.
Point A, point B, point A, point
B.
B dot Y.
I didn't even see that, guys. Sorry, I'm sure most of you are pointing at the screen going, ha ha, I've been seeing that for the last 20 minutes. That's okay. That's what happens when we're so busy talking about what's going on and not paying attention to what we're typing. Very important there.
Probably even said point B as I was typing point A, but all the same, let's try this now that we've got
this will work
values
right
plugged in.
There we go. There, nice.
So every time we hit the target gets reset, but projectile keeps going because we haven't coded in projectile reset yet. Alright? So, I guess we should turn our attention over to reset projectile.
Yeah, we're pretty much at the very end of all of our gameplay mechanics now. Sweet. Let's do it. What do we need to do for resetting our projectile? Well, it needs to be above the top of the screen.
Right, because if we look at the check that Fire Projectile is looking for, what counts as off screen? Well, simply having the projectile's bottom be less than 0. Now, of course, we can't directly set the bottom. We have to address it by the top. So we're going to have to take it by the top and move it enough off screen so that it's completely off screen.
Right.
We saw something like that when we did the target. We had the target set just off screen by using the negative target's height. And so we could do the same thing with the projectile.
Same thing.
So we could take our projectile, set its top to be equal to, or rather equal to the negative projectile height. All right?
Okay. And, yeah, let's go ahead and run it. Nice.
So we have both the projectile and target look like they get destroyed upon collision.
Very cool. Now let's take a look at our implementation plan and look back here at our gameplay mechanics to make sure that's everything in place. We've made it so that we can fire. We've checked for a ground collision. We have handled respawning our target. And of course, when it begins, the target has not been reset to the top, but we can take care of that when we start putting the gameplay into place.
Right, that's not really a concern right now.
Right.
Because that's not the only thing that's still being left out there. We still don't have, the entire game has to wait at a title screen before it begins, and then we even talked about a begin game method for a gameplay method. So we'll just handle setting up the target when we do things like begin or end the game.
Precisely. So we've got firing projectile, we've got checking for a ground collision, and we've got respawning the target object if there is a ground collision, and then we've coded in the project and target collision, and of course that utilized the get center and distant utility methods. Distance and utility methods. Ooh, that was a mouthful. And then from there we simple handled resetting our projectile, and that's it. That pretty much wraps up everything we set out to do in the implementation plan for the gameplay mechanics. Again, we're using our implementation plan as a simple roadmap for constructing our game. And so far, it's working out quite nicely, Logan. So that's going to wrap up this video. Anything else you want to add?
No, just saying that the game is playable.
Yeah.
It just doesn't begin or end.
That's right. And doesn't really, I was going to say, doesn't really have any rules, which is the begin and end for the most part. So in the next video, we will take a look at getting gameplay set up and finishing off Canon. So that's going to wrap it up. Thanks a lot, guys.